It has been a long while since I've made a video, but I've been thinking about my theory recently, and I think it's just time to make another one. Now, why haven't I made a video for a while? Basically because I feel that my theory video that I made previously pretty much explained everything. Of course, there was an error in it, which I'm very sad about and upset, but otherwise I really feel like it stood up, and I've corrected the error in the annotations of the video. And it was just that I indicated that coordinates would flip in a time direction but not a space direction after an event horizon transition, when actually they would. So I've laid out an annotation. I don't really want to delve into the error and the implications of it. Instead, I want to talk about the idea of dark energy, because I was thinking about this earlier today. I was not planning on finding a potential explanation for dark energy. I didn't start out like that. I started out in about 2005 to see if I could find an alternate explanation for the dark matter phenomenon, because I didn't buy the current explanation, because dark matter wasn't behaving in the way you would expect anything to behave if it was composed of particles in this universe. And so along the way, let me explain my thought process. See, I've got a background in biology, and in biology you deal with cells. And what are cells? Well, cells are tiny little compartments for chemical reactions. If you really want to break it down to its bare bones explanation, that's all they are. They're little packages that do chemical reactions, and they do them in such a way that the chemical reactions can propagate themselves, even against, well, I can't say against entropy, but reactions that are entropically unfavorable are carried out in cells because there are a great many other chemical reactions that provide the energy for them. That's basically how they work, but fundamentally they're just compartments of chemical reactions. Now, as a biologist, what you learn is that everything that's going on in the cell starts off, well, let's do a eukaryotic cell, since that's what I'm most familiar with. It starts off in the nucleus, where the DNA is. So if you want to start talking about a cell, you can kind of begin with the nucleus and delineate everything, all the cellular behavior from there, because you start with DNA, then you can explain RNA and proteins, and once you explain proteins, you can explain all the mechanism of the cell. So you start with the nucleus. So let's take a biologist like me, looks at a galaxy and wants to know why dark matter is going on. Well, a biologist like me looks at the galaxy and says, okay, what's going on here? Where's the nucleus, is what a biologist thinks. And myself, the biologist, looked at the galaxy. Okay, the nucleus is in the center. What's in the center? And the center is a supermassive black hole. Everywhere we look, we see a galaxy, there's a supermassive black hole in the center. So, okay, there's my nucleus. In order to understand what's going on with a galaxy, in the mind of a biologist, start at the nucleus, delineate outwards. Let's start at the nucleus, the supermassive black hole. So I started looking into black holes, and that's when I kind of tried to develop an alternate theory to explain what was going on, because once I concluded that, okay, it starts with black holes, I tried to figure out where in the world could the cracks in black hole theory be to posit my theory. And after a number of very, very, very flawed attempts, still with a core idea that appeared to be solid, the conclusion that I reached was, and I'm not going to go over any of the other iterations, I'm only going over the current theory. The conclusion is that the Eddington-Finkelstein coordinates, which are used to cross the event horizon, they provide diagonal coordinates that should allow for world lines to travel all the way to the center singularity of black holes. What I discovered was they were based on the tortoise coordinates, and after asking a physicist, I found out that the tortoise coordinates don't even reach the event horizon. And if you enter the tortoise coordinates, if you try to get the coordinates of the event horizon in either the tortoise coordinates or in the Eddington-Finkelstein coordinates, what you get is a term with the natural log of 0, which is undefined. So that means that there's no coordinate for the event horizon in either the tortoise coordinates, and thus neither in the Eddington-Finkelstein coordinates. And this served to me as evidence for my previous theory that I was working on, which said you couldn't cross the event horizon, and it just did nothing but bolster that idea. So you're not crossing the event horizon. This means that mass is collecting around the black hole. Now I have to move on to the behavior of these black holes in order to get to my dark energy point. This is a bit of a long stretch video. Bear with me. If nothing is crossing the event horizon, that means all the mass is building up around the black hole. And as the mass is building up around the black hole, it too becomes so densely compressed that it too starts to become a layer of black holes. And so black holes start emerging from this mass that's around the black hole itself. And so now you have a situation that a biologist like me, well, not a person with a biology degree like me, likes to think about, because there's competition going on. When you have these black holes emerging from this black hole surface, you now have black holes that are competing for mass, and they'll grow bigger or shrink smaller depending on whether or not they collect mass or not. And what you have is a kind of foaming, frothy behavior depending on how these black hole bubbles are competing for mass. Now, this sounds absolutely out there, I know. A black hole that's made up of a bunch of competing bubbly black holes in a big blob of mass. That's what I'm trying to lay out for you. Now, is there any concept in physics to bolster this? I would say yes. Samir Mather has laid out a theory called the fuzzball theory, the fuzzball black hole theory, where black holes can just produce a large amount of gravitational strings. Well, these black hole bubbles would be forming gravitational strings in them. Now, how would these strings behave? That too has a theory precedent, and that is everything from Einstein up to Leonard Susskind. They would behave like Einstein-Rosen bridges. They would need to connect to another black hole, but that's the essence of the theory. So two black holes can connect with these gravitational strings that emerge from these black hole bubbles. It's complicated, but once you get past the idea of bubbling, boiling black holes, the mechanism kind of explains itself, to be honest. And all the math is already there in the Einstein-Rosen transformation of the Schwarzschild metric. But it leads to a very troubling word. A very troubling word to deal with in physics. And it's one that I think might be the reason why nobody's really moved forward with a proposal like this one. And that scary word is extrinsic. The surface of these wormholes connecting these two black holes, these Einstein-Rosen bridges connecting these two black holes, will be negatively curved, embedded, and extrinsic to the universe. Now, physicists don't really deal with things that are extrinsic. Michael throws a ball to Darius. Well, okay, now we know that we can know the weight of the ball, we can know the force with which Michael throws it, we can know its trajectory, its air resistance, everything about the behavior of the ball, of Michael being thrown to Darius, we can lay out in a calculation that is intrinsic of the entire universe in which this experiment is taking place. The whole idea of physical study is that the behaviors you're looking at are intrinsic to the universe in which you are observing them. And the fact of the matter is that my theory demands the study of things which are extrinsic. These embedded surfaces are extrinsic to the universe. You can't see them, you can't travel to them, you can't go anywhere around them. You can only weigh them and measure them if my theory is correct, or rather if my theory is not wrong. You can only do it by measuring the gravitational influences between galaxies forming the dark matter halos and the dark matter interactions between the galaxies. That way you can measure the strings. Is there any evidence that this physical interaction is going on? Forget the whole fuzzball theory idea. What's the physical evidence that this is going on? If I have a black hole spinning over here, and billions of light years away there's another black hole, that black hole will have a common spin. That happens. And if I have a number of different black holes, it appears that they all influence the spin of any galaxy that they have in a common region. So the spins of black holes are all aligning in common directions relative to the black holes around them, even though they're separated by billions of light years. How is that possible? I posit to you it's possible because they're connected by Einstein-Rosen bridges in this behavior that is analogous to Samir Mather's fuzzball theory, although not quite exact because Mather's theory still deals with event horizons that you cross and fall into the singularity. Let's come back again to the word extrinsic. And let's imagine again this behavior of these bubbling black holes. By the way, I'm not exactly sure if this is the correct definition, but a definition for particles that scatter and become more like black holes as they scatter is asymptotic darkness. So this bubbling idea has a term already in it, that things become more like black holes as they scatter. This is a different scenario in which they become more like black holes as they collapse. So, I honestly, I'll level absolutely flat. I don't know enough about asymptotic darkness to say definitively that what's going on here could be called asymptotic darkness, because again, this is a collapsing behavior. So if it is asymptotic darkness, it would have to be collapsing asymptotic darkness, not scattering asymptotic darkness. Or perhaps the behaviors are analogous. Again, that's a region I'm uncertain to go into. Even though it could be collapsing asymptotic darkness or just asymptotic darkness, I want to give it the term that I originally gave it, which is space-time boiling. So this space-time boiling, this bubbling is going on. All of these extrinsic bubbles are popping up inside the event horizons of these the bubbles opening up in the black hole. Now, if you were inside one of those bubbles, what you would see would be an extrinsic expansion, and you couldn't be able to explain it because it would be coming from the mass outside of the event horizon. And I think this is exactly what's going on in our universe. That's where dark energy is coming from. It's another extrinsic interaction. And we come back again to this scary word, extrinsic. That our universe is very much like a bubble in one of these black holes. That mass and energy is collecting around our universe in a higher dimension that is extrinsic. And because that is collecting, the black hole of our universe is actually expanding. It passed a point 13.8 billion years in the past where the mass and energy of this bubble went past what's called its Schwarzschild radius, which is the point at which something is a black hole. If you collapse something down to this radius, it becomes this bubbling, boily black hole. And likewise, if you expand above it, which is something that apparently only dark energy can do, you'll shatter the black hole and you'll get a universe like this one. So our universe, according to this theory that I've worked on, and I don't know if it's true or not. I really don't. Honestly. This could be all wrong. But according to the theory that I've worked on, the universe is like one of these black hole bubbles, and it's expanding because extrinsically it's collecting mass and energy that expand it outside of the universe. Terrifying thought. Okay, as I understand it, 5% of the universe, roughly, is energy and mass and space that we understand. 95 of it is dark matter, dark energy. We have no idea what it is. And confronting dark matter and dark energy is far more inconvenient to the physicist than he previously believed, is my notion. Because all physicists are looking for intrinsic definition for what's going on in the universe. And my theory is demanding you cannot look intrinsically anymore. What you're looking for is now extrinsic. It exists outside the bounds of the universe in which you experiment. And that is a very, very terrifying notion for someone who wants to deal in physics. Because where do we go from this? If we're talking about now we can no longer do experiment in the universe, then we really don't know what we're talking about anymore. Maybe they don't even know what they're talking about any more than I do. That's how I feel sometimes. I don't know. I don't know at all. All of this could be wrong. But if it's not wrong, it means that the future of physics lies outside the bounds of the universe in which physics is studied. It's a scary thought. But that's the direction that my theory appears to be taking everything. Don't worry about what I say, honestly. Keep reading the textbooks. and understand that I have an objection to them at the event horizon of a black hole, and only there. Okay, well, there and below. Everything there and below, I have objection. Now, that objection could be wrong, and maybe everything falls into a singularity and becomes this little singular dot that somehow still demonstrates gravity and separates particles by, well, you can't do the exclusion principle. There's nothing really left to say that the singularity can make forces, but maybe it does. So, I am rambling at this point, but I want to come back to the center idea that dark energy is extrinsic, that the behavior that the universe is going through right now is analogous to a single instance of asymptotic darkness in a collapsing frame, that you cannot cross black hole event horizons, and that, dark matter is caused by Einstein-Rosen bridge interactions between supermassive black holes at the centers of galaxies, and that all these still really stem from that one concept that I did mention, that you don't cross event horizons. That's really like, that's it. If my statements about the event horizon are not wrong, then anybody should be able to take these theories, this theory that I've put together and expounded out, and rebuild it all back up. Now, let's say that I'm right about the event horizon and wrong about everything else. Well, fine. Then that's what's going to be illuminated and elucidated. I don't care. Great. But I think there's a convergence of all the evidence that I've seen that still leads down the path of Einstein-Rosen bridges and asymptotic darkness within black holes and extrinsic expansion of the universe by the same behavior of a single instance of asymptotic darkness in a collapsing frame. I think that's where physics is going to drive everything. That's just going to be the natural course of things once we get over the big event horizon problem. It's just going to be very obvious. It's all going to come down to whether or not extrinsic solutions will be acceptable in an inherently intrinsic field of scientific study. Now, I've wrote a basic paper that kind of outlines, I wanted to explain to someone who knew nothing about, who knew less than me, who doesn't really know anything about this stuff, someone who knew less than me, I wanted to explain the ideas of Einsteinian gravity as I understand it. And I've tried to have it passed off to several people. I haven't heard any objection that I've said things that are absolutely wrong. So I'll leave your judgment up to you. Remember, unprofessional, independent researcher. I am far more like a newspaper reporter than I am like a physicist. Far more. But these are the conclusions I've drawn. I'll also leave a link to my actual theory video. Again, it's got that coordinate error in it, but other than that, I feel very solid about everything I've said in it. And I'd like to thank you for tuning in for my first video in quite a while. Hopefully soon I'll have a better camera.